Hello, good evening, guys. Welcome to Origin's computer classes. In last video, we have discussed about some fundamentals of recursion and how it works. So, in this lecture, we shall be considering some of the basic problems of recursion for the beginner level. So, let us take the first problem. So print 1 to n without using loop. So this is a very simple problem. So we before going to recursion, let us first think of how we used to do it using the loops. Say for 1 to n, printing one numbers from 1 to n, we usually used to consider a for loop with a variable. Say for int I is equal to 1, I less than equal to n, then I plus plus opening brace, and then we be printing with printf modulus d, and then I. That's all. So in this loop, if we check this loop properly, here I starts from 1 and I ends at n, then and it continuously does a task of printing. Okay. So if n is 5, then it will print from 1 to 5, and if n is 10, so I will be continuously updating with I plus plus and so on. So recursion is nothing, just the conditions will remain same, but the approach will be different. Like in loop, we are going stepwise, and in recursion, we will be doing this same approach only, just by continuous function calls. Okay. So for recursion, what we consider first, the base case, and then because base case is the terminating condition for recursion. If we consider a loop, then the terminating condition is when I becomes same as n, and if I is greater than n, then loop will stop here, right? So if we consider the base case of this particular problem for recursion, first if we define a function for, let us define a function, say void, say sum, not sum, digit, say numbers up to n, numbers comma n. Okay, this is a function name I am taking, and it will be considering, of course it should consider the n, that is the number up to which we should print, and after after that the update, some updating variable, right, which can continuously increase the number. So say I am taking two parameters, n and I. Okay. In this scenario, I should increase, and so what is the base condition for this problem? In case of loops, for loop used to stop whenever I becomes equal to n, right? So similarly here we can consider the base case, that is the terminating condition, that if I equal to n, in that case, so when I becomes n here, right, so that number we were printing, and then finally when I becomes just greater than n, say if it is 5, then if I becomes 6, at that instance the loop will stop, but 5 will still be printed, right? In this case also, that means if I equal to n, so it will print that last value, right, and then it should stop. So let us print the last value, and then we will be moving out of the function. Fine. So here printf I, and now return, closing of if. Otherwise, we will be continuously calling this function to update the value of I, right? So how to call the function? So return, we can return num n will remain as it is because n is a fixed number. So which should increase, which parameters should we update? Obviously I, right? And closing of the function. So how is it working? Say this is a variable, and yeah, before this we should be continuously printing the value of I because our task is to print all the numbers up to n, right? So this is what. So how will it be working? Say from the main function, as the program starts from the main function, we shall be calling this function with the value of the number up to which we want to print. So say suppose we want to print up to 5. So obviously 5, and I represents from the main function from the perspective of user from which point up to 5. Like we should also mention the starting point, right? So if user gives 1, then we will be printing from 1 to n, or otherwise if user gives 2, then we will be printing from 2 to 5. So starting and ending both will be decided by the user itself. Okay. And yeah, so that's all. So the working of the function will be something like this. Say if n is 5, then this num function will be called, right? If this num function is called, then in that case we can consider n as 5 and I as 1. Okay, so this is how we can represent. This is the calling of the function. Let me show you by method. So from main function, it approaches this area, right? So from here, void num, we can consider void num, just the function name, because void means no return type actually. Void num of 5 comma 1. For this function, if I equal to n, so 1 equal to 5 is definitely false, right? Therefore printed. So we just come back to this step, printf printf I. So in the output we will be printing I, value of I. In the output 1 is going to come, right? In the output 1 will be printed because this if condition is false, and these lines will be executed. In the output we are supposed to print 1 first, and after that return num n 5 comma, so very sorry, it should be I plus 1 because I is updating, right? Just a second. So it should be I plus 1 actually. Void num n I plus 1. So num 5 comma 1, then it should call num n 5 comma 2, right? Because after printing, this line executes return num n 5 comma n comma I plus 1, that means 5 comma 1 plus 1, that is 5 comma 2. So num n 5 comma 2. Fine. So in this statements of num n 5 comma 2 again executes these lines, right? So if I equal to n, so if 5 equal to 2, that condition is false. 5 equal to 2, this is false. Fine. So we do printf, print, definitely we will be printing 2, and then so print 2 means in the output 2 is going to come, 2 in the next line, 2, and then again we call. So after this line will be executed, then num n. So this after print 2, so return num n n comma I plus 1. That means this function is again going to call the next, right? So num n 5 comma I plus 1, that is 3, right? 5 equal to 3, that is false again. So print 3, in the output 3 is going to come. So this is, as you can understand, in the same way 4 will be printed. This function again calls num of 5 comma 4, num in 5 comma 4. So 5 equal to 4 is again false. So print 4. Okay. Print 4 says that in the output 4 will come again. Okay. And now in num in 5 comma 5, and now 5 equal to 5. This statement is true, and as this statement is true, so this if condition becomes true, and we enter the if, that is print, again we print 5, and then return. Now in this statement, after return nothing is given, so that means we are going to exit from this particular function, right? We are going to exit from this. Return says that exit from this step, this particular step. That means it will again approach. After return statement, it is going to go to the previous step, and in the previous step, after this return statement, there was no task actually. So therefore it again, because of this return statement was there in this step, so that means this step was already done, because due to this step 5 comma 5 was called. Therefore return means again exit from this also, so this is going to return back to this portion. Okay. So in the same way, this also again goes back to this part, right? This function. Okay. in the similar fashion. Okay, in the similar way, this goes back to this one, this part. Okay, this function particular 5 comma 2, and finally exit, because at each part after this return num comment nothing was there to do, right? No task was there, and there was no addition or something into 10. Therefore we return back, ultimately this is the output. Fine. Okay, so let us code it right away. Let us check if the output is coming properly or not. So print, so first problem is print 1 to n. Okay, so print 1 underscore n dot c, hash include, where we should include the stdr package. The general syntax of C, stdr dot h. Let us define the main function. In the main function, we will be calling the main function. And the main function is not returning anything as such. We are considering a void function, right? So there is no return type for this function. It is just printing some values. Okay. And main will be taking, we will be calling with two parameters, the starting point. So say the starting point is 1 and n will be given by user. Okay, oh, let us take say printf enter number of terms in 10. Scanf is taking some argument, say mod d, the format specifier for integer data type, and in. Okay, so this is our main function printf. We are calling this main function. That means we need to define this main function now. Fine. Main function. So we are taking two parameters. The starting point, let it be I, and n. Fine. Base condition was our if I equal to n, then we will be printing the final value printf mod d comma I, the final value. Okay, and then return. Otherwise, oh, we don't need to add else actually. We can add, but no, we don't need, because this if condition will be true only once, and after when this is true, this will return our exit from the function. After that, next lines will never be executed, right? Therefore, we don't need the else. It's unnecessary. Okay, we can directly write here printf mod d comma I. Then we can call the function with I plus 1 comma n. Okay, so that's all about our function. This is the coded approach, right? Okay, so the everything is fine here. So let us take, so void main I comma n. Oh, here we need to mention the data types of the variables, because these are the formal parameters where we need to mention the data types. And next we have, so everything should work fine. Let us check the output. Just a second. enter number of terms, say 5. So it is printing 1 2 3 4 5, but uh, we should include spaces. We should print it in a proper manner. Say in the next line, it is come in the congested manner. For next line, we should add slash n. Okay. So these are small syntax issues. Enter number of terms, so 5. Okay, now it's coming properly. With 10, up to 10 it is getting printed, so our code is working fine. So hope you understood this problem. So from 1 to n we can just print it as it is. So let us now look for the next problem. What is it? Sum of the digits using recursion. So sum of digits, uh, say we will be given a number, say 1 2 3 4 5 or 541, and then the 541 should print 5 plus 4 plus 1, that is 10, sum of the digits, right? In case we have implemented this problem previously using while loop, but here we are supposed to implement it using recursion. So again, like the previous problem, let us first consider the iterative approach, then we can proceed for the recursion. We just need to look for the terminating condition and the initialization, right? So let us consider it. Okay, so let us consider the iterative approach first. So if we were given in iterative approach, if we were given a number, say n, for that n, we used to run a while loop while n greater than 0. And for extracting digits, we used to write just a simple mathematical syntax called n modulus 10. See, modulus means bringing out the remainder. So if we divide something by 10, then the remainder is always its last digit, and that we used to consider. So extract each digit n modulus 10, and in a variable say sum is equal to 0. We used to store the sum of the digits. Each time we used to do sum is equal to sum plus digit, and n is equal to n by 10. Okay, so this was our code. So if n is 541, then first in digit 5 will come. I mean, sorry, 1 will come. Then sum is equal to sum plus digit. Sum will become, if it, let us consider 541. So digit at in first will become 1, and then sum is equal to sum plus digit. So sum is going to become 1. N is equal to n by 10. That means n is equal to 54, right? Because n by 10 means, so yeah, other than the last digit, whatever remains in the number. Sum is equal to sum becomes 1 in this stage. After this n becomes 54, so it goes back to the condition again. So 54 greater than 0 is true. That means, so digit at this stage becomes 4. Sum is equal to sum plus digit. So sum is presently 1, and 1 plus 4 is 5. So sum becomes 5, 1. That means 1 plus 4 plus 4. So this whole turns out to be 5. And then n is equal to n by 10. So that is 5. Okay. Again 5 greater than 0. So in this way digit becomes 5 and sum becomes 5 plus 5. And this whole together becomes 10. n is equal to n by 10. So 5 by 10 is 10 zeros are 0. So quotient becomes 0. 0. 0 greater than 0 is false. And finally the loop exits, stops running, and then the final value of sum is 10. This is how iterative approach used to work. So in this approach, what was our terminating condition? That is, uh, when n becomes less than 0, then or if even if n equal to 0, n equal to 0, at that instant moment the loop was getting stopped, right? And similarly, therefore in the recursive approach, what is going to be our base case? That means the terminating condition again. So in the recursive approach, so if we consider a function sum of digits, which is going to return us the sum of all the digits of the number. Okay, in the recursive approach, say void, sorry, not void, int sum of digits. So it is going to accept only one parameter, say n. Okay, and other than that, I think we should require nothing, because the digit actually means n modulus 10 only and n by 10. Okay, and we will be updating the function itself here. First, let us consider the base condition. So when the function is going to stop, when n becomes 0. And if n becomes 0, in this case, we can return 0, because at that stage, nothing is getting, when n is becoming 0, is anything getting added to sum? No, because 0 greater than 0, it is false, right? And that means we are exiting the loop. Fine. So when n becomes 0, nothing is going to add it. If nothing is going to add it means we can add 0 actually. Adding 0 makes no sense actually. The number remains as it is. Okay. Otherwise, we can return now. In the recursive approaches, what we do is actually if you have seen my last video, if you have watched my last video, then you should know that the present problem actually calls it sub problems, right? When we are considering the factorial of numbers, so when we are say calculating 5 factorial, so 5 was calling 5 into 4 factorial, right? And then that means function was being recalled for that particular purpose, for calculating the 4 factorial. And again 4 factorial was 4 into 3 factorial, that means 4 into that same function is called with its previous value, right? In this case also, we are actually adding the digit with the previous one, right? Say when we are taking 1 is getting added to sum first, that is fine. After that, when 4 is coming, 4 is actually getting added to the previous one, right? If we consider here 541, then 1 will go first in the function, and after that 1 is going to call that, like, if I consider 1, right, from 541, if I consider 1 here, so 541 will say, what we are actually doing is 5 plus 4 plus 1, right? So 5, we can say it's 1 plus sum of 5 and 4, right? Fine. And so 1 plus sum of 5 and 4, and this sum of 5 and 4 again says that this means, so basically sum of 5 and 4 and 1 comes back to this step, and then sum of 5 and 4 will definitely say that I am actually sum of 4 plus sum of 5. And now sum of 5 is a single number, so sum of 5 is definitely 5, right? And hence we are calling 5 plus sum of, so nothing is remaining. That means it should call sum of 0, and for 0 we are returning 0 actually. So this is going to return 0. Ultimately it's 0 plus 5, so this is going to get 5. So let us, so ultimately this is, if you observe, we can actually pass here 54, and in the next step we are just passing 54 by 10. Here actually we are passing 541, and in the next step we are actually passing 541 by 10. So updation of n, just as simple as that. Here n was present, so n is getting updated, right? N is getting updated with its previous sum. 541 by 10 is 54, and 54 by 10 is definitely 5. So this is what we are exactly actually doing. So we can consider the digit first, that is n modulus 10, right? N modulus 10 will bring the digit, and it says I am n modulus 10. N says I am the sum of means n modulus 10 plus the same function we should call, because sum of the previous digits, right? N modulus 10 plus sum of the previous digits, so sum of digits. In order to access the previous digits, we should always update n by 10, right? And that's all. This is all about our function, and we close the function here. Okay. So it should work in the same way, 541 by 10, and after that, when sum of 0 becomes 0, the 0 is sum of 5 plus sum, 5 plus 0 is 5, and this 5 is returned to its previous stage, because this particular function is calling this function, right? Just a second. If I draw this here, so this is calling, so 5 is being returned here, so 4 plus 5 is 9, right? So this is returning 9. Actually, let me redraw it here properly. This is 541. If n is 541, we are calling, I'm not writing the main function here because I will be coding it directly. You, by this time you already know how to write it, I hope, right? So recursion is very simple, as you can see. It's just that you need to first observe the iterative approach, and it just observes the starting and the terminating condition. Other than this, we are just calling the function with the new value, right? Nothing else. In whatever we used to do in iteration, it was just we used to use another loop variable, nothing else. Other than that, everything is same. We are just using these variables were extra. These has no work actually. In recursion, it says that I can do it just by the starting condition and the terminating condition. Starting condition will be sent from the main function itself, and terminating condition is definitely the base case, and we just update the function with the new value, right? And so let us see the working. So sum of digits is called by 541, 541, and it calls sum of at 541 sum of digits. 541 equal to 0 is false, so return 0 is false. What it returns is, it returns n modulus 10. So what is n in this function? 1, right? So 1 plus, again, sum of digits. It says that I am the last digit. 541 says that I am last digit, that is from 1, plus sum of, now 541 by 10 is 54. This 54 actually represents, it will again have to, it will again calculate, because 541 by 10 is 54, and 54 again, because we will be newly calculating the sum of digits for 54, right? After eliminating the last digit, what we remain with is this. Okay. So at each step, what we are actually doing, we are breaking the problem into subunits. 541 means it is the sum of 5, 4, and 1. And then in the next step, it is calling that at 5, 4, 1, 1 plus sum of the previous digits, that is 54, and in where 5 and 4, that is it. And then we are again calling, this function is again saying that I should be the sum of 4 and sum of 5, right? So it is saying that 5 plus, we need, we can have it here, it's 5 plus sum of, sorry, not 5, last digit was 4 plus sum of digits 5. Okay, and as you can see, it gets reduced. That's again 5 plus sum of digits 0. Hope you can understand. At 54, again of 54 equal to 0 false, so we returned 4 at this line. 54 modulus 10, 4 plus sum of digits. 54 by 10 is 5, and 5 is 5 plus sum of digits. 5 by 10 is 0, right? And sum of digit, at sum of digits 0, that means n equal to 0. And if n equal to 0, what we are returning? We are returning simply 0 at this stage. So this returns 0. Fine. This returns 0. After returning 0, naturally return means exit. So exit means, that means, so if it returns 0, and so 5 plus 0 is 5, definitely. And this 5 after exiting, that means exiting means what? It will go to the previous stage who has called this function. So this part has called this function. So 5 is returned here. So this is 5. Okay. Value of this function is 5. Right. 4 plus 5 is 9. So 9 is, who has called this function? Obviously the previous stage. So here we return. In the same way, how you come until the end, from the same route you need to return back to all the previous paths. So 4 plus 5 is 9. So the value of this function becomes 9. Right? 1 plus 9 is 10. And so ultimately the value of this function becomes 10. Definitely. And finally, therefore, we get the sum of the digits, that is 10. So 10 is the ultimate value, right? So let us write this code. So sum of digits dot c. Fine. Okay. So it will include the same code actually, just with a few changes. I am just uh, discarding this function, and it is going to call with sum of digits, sum of digits n, enter a number, enter a number. Right, so printf enter a number int n, and we are passing the value of n to sum of digits. That means we need to define this sum of digit function. Okay, now this sum of digits is going to return the sum, so we need to store that means it should have a return integer type of return, and if that is so, we need to store that in a variable. Therefore we are storing this in a variable called sum, say, and ultimately we will be printing that sum. Okay, printf mod d comma sum, because this final value 10 needs to be stored somewhere, right? And sum of digits is of integer data type, so we are considering an integer variable. These I have discussed in my previous videos, where I discussed about in the video of functions, right? So let us consider sum of digits, in sum of digits int n, that is the formal parameter, and print if I equal to, if, what was our base condition? If n becomes 0, so we are going to return 0, right? Return 0. Otherwise we were calling sum of digits with its previous digits, and we are adding the present digit with it, that is n modulus 10, right? So this is getting added and returned here. Of course, return this. Okay, so that's all, and it should properly calculate sum of the digit. So let us now check the output of this code. If we consider 541, it should give 10. So yes, sum of digits is 10, right? Sum of digits is 10. Let us take a greater value, say 1, 9, 2. So 8 plus 1, 9, 9 plus 9, 18, 18 plus 4, 22. Okay. So this code is working fine, right? So our approach is correct. So today, in the next lecture, I will be discussing the problem 3 of recursion, that is decimal to binary conversion using recursion. Okay, this is a very important problem. That is why I'm keeping a separate video for this. Very important, right? And I'm as giving some assignment problems. If you can do, please comment it out in the comment section. The assignment problems are such that uh, just similar kind of print. I have printed from 1 to n without using loop, so you print n to 1 without using loop. So I was printing 1 2 3 4 5. You need to print 5 4 3 2 1, right? That's all. Loop. And second is you can print. So as we have learned about the sum of digits, just consider uh, writing the following programs using recursion, following number programs using recursion. So say check Armstrong number using recursion. Okay, because you have learned the sum of digits, and in these sorts of number programs, we actually just perform cube or to the power 4 and do the sum only, right? Just try it out. If you can do it, ju- just write it in the comments section. Otherwise, we'll be discussing in the next video along with problem 3. Okay, next upcoming videos. Okay, check diserium number using recursion. Okay, so Armstrong number was nothing like, say, if you are given 153, so the number of digits in 153 is 1 cube plus 5 cube plus 3 cube. That is again coming to be 153. So those sort of numbers we call it as Armstrong numbers. Okay. If the number of digits are 4, then each digit should be to the power 4. Say 1684 or something like that was another example of Armstrong number, right? And the diserium number is, so the digit to the power the position of the number and the sum of those should be equivalent to the number. That is called the diserium number. So a few examples I am writing here for Armstrong number. If we consider, say, for Armstrong number is, first one is 153. So you say 153, comma, say 371. Okay, 1634. So etc. And for diserium number, you can consider diserium number. It's like 135. Okay, 518, 89. These. So in 153, as you can see for Armstrong, 1 cube, as I said, 371, 3 cube plus 7 cube, 3 cube 27, 7 cube 343, plus 1 is 371 only. Here it is 1 to the power 4 is 1, 6 to the power 4 is 6 cube, 6 square is 36, 216 into 6. That comes out to be 1296, and 3 to the power 4 is 81. So if you add all those, you will be getting 1634 again. In case of the ICM number, this is 1 to the power 1 plus 3 to the power 2, right? Or if we consider it from the reverse direction, just let me check once. Yeah, so it's 1 to the power 1 is 1. 3 square is 9, so 1 plus 9 is 10, and 5 cube is 5 is a third position, so 5 cube is 125. 125 plus 10 is 135. That is why 135 is discrete number. And same goes for 518 and 89. So that was all for today, for this lecture series. Thank you for attending.